John and I are going to talk to you today about using your database. So we all know, it's 2011 and relational databases are totally passé. I mean, we have all of these fantastic options that have been coming out lately. We've got document-oriented databases like Mongo and Couch. We've got awesome key value plus stores like Redis. We've got the super scalable options like Cassandra and React. And relational databases, I think at this point we can all agree they're done. They're over. So that's what we're here to talk about today, because relational databases are actually awesome. So some of the things that we love about relational databases, first, you can have many representations of the same data, and there's really no limit on how you can represent your data, assuming you're okay with rows and columns. But you can put together, you can take any data that's in a relational database and represent it if you put together the right query. That's not true of pretty much anything else I've mentioned. So in a document-oriented store, you can represent data that lives in a single collection, right? But you can't kind of pick some from one collection and some from another, in Mongo anyway. Again, in Redis, if you're just asking for a representation, you're pretty much stuck. It's awesome, don't get me wrong. But you're pretty much stuck with what lives in one key in a single operation. And of course, we model data that has complex relationships. There are certainly situations in which documents are a great and natural fit, but a lot of times, everything relates to everything else in various ways, and relational databases, of course, as you know from the name, are built for that. And finally, we have transactions. It's robust, and we'll talk a little bit more about ACID down the line. But these are some reasons why we love relational databases, and we want to talk about them today, even though they may not be the most exciting thing that's being talked about in the community right now. So in particular, something that's bothered John and me for a while is relational databases, or the way we use relational databases, specifically in Rails. I assume most people here use Rails. I know it's not Go Rails Co, but that is the way it works around here. Rails treats the database as sort of a place to dump data, or a place to persist our objects, right? It abstracts away a lot of the database's functionality. And abstractions can certainly be useful, but Rails really encourages you to do all of your data-related stuff, or a lot of your data-related stuff in Ruby. That's one of its calling cards is you do stuff in Ruby, and not really interact directly with your database that much. Migrations are one of the things that I think drew a lot of us to Rails, and they're really cool. But there's a lot that you can do with your schema that migrations don't explicitly support. So you have kind of this low bar to doing the stuff that migrations do, and then suddenly you're like, at the margin here, suddenly you're having to do a lot more work. So that really discourages people, I think, from using all of the schema options that they have. So in the end, as Rails developers, we tend to underuse the power of this really powerful thing. So I think one of the reasons why some people have gotten discouraged about relational databases is you see all of the power of Mongo because it's new and it's like, wow, it can do all this stuff. Redis, wow, it can do all this stuff. But in fact, wow, relational databases can do all this stuff, and that's what we're going to talk about today. But we may have forgotten that as we have been a couple layers of abstraction out. So just a quick overview. Why we've grown disillusioned with relational databases. Some of the things you can do with SQL that are really cool. Things you can do with your schema that you might be aware you can, but you can't, and we're going to remind you of that stuff because there are good reasons to do it in your schema. One great example of that is enums, and we'll talk about that. Again, in your schema, relational integrity, the actual concept of relations within the database. An alternate design pattern from what Rails hands us for dealing with inheritance in relational schemas, and puppies. So, first puppy. This is a yellow lab, I think. John's going to take it away.
So a lot of times, I've wondered kind of why relational databases are the thing that people have chosen for a long time. And if you look back, relational databases really are the thing that was chosen because they are a middle ground in a lot of ways. One way that they're a middle ground is they provide this tabular format for dealing with data and keeping data consistent, which is really important when database systems need to keep their integrity over time. And you imagine like a long time ago with hardware going down that you needed something that could be stable. So that's where like the idea of acidic transactions are coming out. And that's where relational databases really find their fit, is kind of just in a middle ground. They're not particularly performant. They're not particularly great at accessing data. They're just right in the middle of everything. They fit a lot of use cases. So I want to talk briefly, before we get started, about scale and replication versus sharding. So with a database like a key value store or a document store, it's really easy to take it and kind of shard it out into pieces, split the data into pieces. And the key difference comes with the key value store's non-need to be able to make joins between different elements. So I can put something on a machine, I can put it on multiple machines and replicate it, and I don't ever need to ask for something that will end up looking for something that will be on a different server and need to join that data together. A relational database has that problem. So typically, not very good at sharding, but okay at replication. And just while we're here, we should talk about graph stores and their sharding strategies. So much like the relational store, graph stores, when they shard and when they scale, the sharding needs to be domain specific. And it's hard to define domains for a graph. So you have a lot of interconnected nodes, and there's not really any kind of clear partitioning you can make. So if we go back to computer science course, you probably heard Edgar Cod, and we learned a lot about normal forms. So let's just start at the beginning. First normal form. First normal form says that there should be no duplicate rows inside of an individual table, and that any individual intersection at a row and column should hold exactly one value. Then we go into second normal form. In second normal form, attributes depend entirely on concatenated keys. So if you have two primary keys inside of a table, all of the elements that are inside the row where those two primary keys are depend directly on those two primary keys. In third normal form, there are no non-key dependencies. So that basically meaning that you should never have a table that's branching off of a property that is not a key. And that's where foreign keys start to come in. If you want to keep going down the line, you have BCNF. That also was made by Edgar Cod. And then a whole bunch of people started making ones that weren't him. And I think that this is a really strong reason for why everyone hates relational databases. So you get buried into this normalization. You see these things as rules. They're things that you have to stick to normal form, or your database is going to suck and it's not going to scale and everything's going to fall apart. But really, these are not rules. They're guidelines. People need to embrace the fact that you can have data duplication inside of a relational database. And that sometimes if you have an object that has another object that depends on and then another object down the line, it doesn't hurt to put a key in the middle so you can shortcut the join to the faraway table. We're doing all this crazy denormalization inside Mongo. Why not do it inside the relational data store too? So this term is an actual thing. It's awesome. Object relational impedance mismatch. So this is the idea that the reason that relational stores are not working for us these days is object orientation. And that when we started to make the move into object-oriented programming, we tried to make a direct correlation between a table and a model, or a table and a class. And it just doesn't make sense. A table is not a model. Objects have nested attributes. Objects have properties that are other attributes. It's just not a direct correlation. So this is kind of how we've gone astray. Let's look at some features. Transactions. Acidic transactions are talked about all the time. So just to run through for anyone that doesn't remember computer science class again, atomicity means that the smallest thing that we can do to a database, an individual transaction or an operation, will either succeed in whole or fail in whole. Consistency means that after we complete an operation, any kind of relations that we have will be completely satisfied if they're specified to be satisfied. Isolation, which is that were I to make a change, the status of what I'm about to change is not going to disappear on me in the middle of the operation that I'm trying to complete. And some strategies we use to deal with this, you've probably heard about dirty reads a lot recently. Dirty reads are a way of so you still block when you're going to write inside of a transaction, but you allow reads on tables that are blocked by other concurrent accessors of the database. Or MVCC, which was mentioned earlier, this is multi-version concurrency control. Basically, it means that there are multiple copies, and MySQL and Postgres work this way. There are multiple copies of the data that you're editing inside a transaction that are sitting inside the database. It's just that when you go to access it, you're just accessing the most recent copy. And it's doing that all underneath the scene. And these are features that we're now seeing come into the databases we're developing that are schema-less. And durability, which means that when the database tells you that the operation is complete, that operation is guaranteed to be persisted. The next time you come back for it, it will be there. It won't just disappear on you when the system crashes 2 seconds after the transaction completes. Bulk inserts. Everyone freaks out about these bulk inserts. So are they really that big of a deal? They're a huge deal. So these times are all in milliseconds. You have 1 column and 5 columns, 100 rows, 1,000 rows, 10,000 rows. So a 10,000 row bulk insert, which is, I agree, amazingly huge, is nearly 11 times the runtime on 5 columns. Halving. So we use group by a lot. Group by is great, and the problem is that when you use a group by, you can't do any kind of a where clause on the operation that results from the group by. But there is this thing called halving, which we don't really use in Rails so much. Halving can do something like having count greater than a certain amount, or having sum greater than a certain amount, or less than a certain amount. So let's look at this problem. This is a problem we look at pretty often. I want to select where my name is John, and then if it exists, I want to update it with a new value for lang equals Ruby. Otherwise, I want to insert it with name equals John, lang equals Ruby. Everyone probably sees the problem with this. And the problem is that between the time that I did my initial select and the time that I go later, something could have happened in the database that made the record exist. So actually, when I write this statement in my code, I need to surround the whole thing with a try except and catch the case where a duplicate key exception is thrown from the database. But upserts, insert into people where these values on duplicate key update lang equals Ruby. This is a feature that exists. What's that?
Does that work with Postgres?
I'm not sure offhand. So I'm working right now on something that's kind of an adapter level thing. I know that there's something like this, but I'm not sure. Maybe someone knows upserts
Ryan.
in Postgres.
Yeah.
Yeah.
So the question was, does this work in Postgres?
Sorry. So next problem, pagination. It's a pretty common problem. So I want to go select all of the people where the face is awesome. All the people that have awesome faces. Right here. I want to limit 10. I want to offset 20. So I want the second page. And then I want to be able to show something like 10 to 20 out of 500. So I go back and I get the total count. We do this all in our plugins and everything, right? There's actually this thing called found rows, where you can execute a statement, and before the star, or before you say what fields you want out of the database, you say SQL count found rows, and that tells the database, basically, when you execute this query, there's a certain thing that you're going to find, and you're going to find, right before you execute the limit and offset, you're going to see the full scope of what is possible to be put here. And when, just before you do the limit and offset, take that value and store it in a variable, and then let me access that variable later with found rows. So The found rows is really cool because when you go for found rows, it's not re-executing anything. It's just pulling the value that it stored in the previous query, as if the query were run without the limit and offset. So an aside on performance, I'm going to give a shout out to a gem real quick. People do selects a lot. No, you don't. Just kidding. You don't do selects. No one does selects. Selects are really valuable, especially when you have like a text field on your database, and that text field has a blob that's a bio of the user. And if you did a select, you would notice a really big performance increase, but a lot of us kind of skip that because it takes time and it makes the lines go over 80 characters, and you don't want that. So there's this gem called Slim Scrooge, and what it does is, over time, it'll first try to execute the query as if it's just grabbing the ID of the row. And then as columns are accessed that it didn't actually grab from the database, it'll maintain what it actually used over time. So when you first start your server, it's going to be a little bit slower, but over time, it's only going to select exactly what it needs. Where this falls apart and where it didn't work for us is that if you have a very large application, storing the line numbers and locations takes up a lot of memory. So if you have a small application, Slim Scrooge is a great way to go. If you have a bigger application, you shouldn't be using Rails. So also check out string length or length. Length is the MySQL equivalent of string length. Check out left. So left is a string operator that gives you the leftmost n characters of any string. And you can put it on any column. And you can say, select name where left of name, comma 4 equals John. All of the names that start with John. You got right. You could probably assume what right does. Concat multiple strings together inside the database. They didn't just add these functions to the database systems because they thought they'd be cute or like it'd be a funny joke. These are actually like meant to be used. Reverse. I don't know what you're going to do with that, but you can use it. You should also check out this. Did you know your database can do regular expressions? And they're POSIX regular expressions, and they're real, and they're not slow. So you might add a little, it all depends the amount of load that you're putting on your database, whether or not you actually want to do this, but it might be something you'll consider. Cast. So cast, if you know the type that is inside of a string is actually an int, you can cast it to an int. It'll come back as an int. You don't have to create 2 Ruby objects in order to represent what comes back from the database. Interval. You can do date calculations directly in SQL. You can say all the things that happen in the next 20 days, the next 5 minutes. You can do that. Puppy break.
That's a good one, right?
That's a good one.
Yeah. John thinks that my puppy selection is spotty, I guess.
At times.
OK, so we're going to look at a few things in the way we define our data. So the simplest thing, we want to make sure that a column has a value. So of course, we watch the screencast and we use validates presence of, and we're done, right? And when we write our migration, we just say t dot string name, and oh great, we have a column named name, and then we validate the presence, and it's there. Well. This is probably no surprise to anyone, but there is a concept of a nullable column and not nullable column. And if we know that a column is going to have data in it, we can just do this in our migration. So this is not an example of something that migrations don't support. And why would we bother to do that? Well, first, SQL implementations actually have to store an extra bit on nullable columns and it just holds whether for each row, whether the value is null in that row. So we're wasting space. Granted, it's just a bit, but every little bit counts, especially at scale. And more to the point, we have no real guarantee that we have a value in this column just because we have a validation. So there are lots of ways to get around validations. We can do save validate as validate false, or just save false in Rails 2. Or we could have something else communicating with our database, perhaps. But even if we don't, There are plenty of ways for this to go wrong. So not null columns, it's just not possible to have a null value. Also, on the not nullable side of things, because of this issue of storing this extra bit, and we really want to be conservative with the amount of space that we require, or that we use. I prefer for like varchar columns and text columns to store just an empty string if there's no difference semantically for my application between an empty string and null. And then you can just use the present method that Rails provides you to still have it feel right in your code. But there's really no, I don't see, unless there's your application actually makes a distinction between an empty string and null, which certainly in some cases it will. Just don't bother with making those nullable. Now it's a little hackier. I mean, there's no non-hacky way to do that I can think of with other data types, but at least for string types, that's just, I don't know, one way of living. Moving on to column length. So validates length of, or validates with a big hash in Rails 3, including length. That is very versatile, right? So we can do minimums, we can do maximums, we can do ranges, we can do all sorts of things. But in particular, where a maximum length is concerned, our database supports that too. And again, one of the reasons, so we have the limit option there. And that, by the way, is not just for varchars, of course. It's the maximum size of numerics as well. And what's crazy about, I mean, it's pretty crazy, is that we max out our varchars and our migrations if we don't supply that option. So we max it out to 255. And that's a lot, and it's a lot more than we usually need. So we end up making our on-disk representation much bigger. And at scale, that makes a big difference. So there's a big difference both in the size and then the more data there is per row, the more work your SQL database has to do to actually pull it back. So really, unless you're thinking to yourself, by gum, I need all 255 of these characters, you should always be putting a limit on your column lengths. Uniqueness. This is the craziest one, right? We have validates uniqueness, and it just doesn't work unless you happen to only ever be running a single instance of your application. So let's look at a little example. So we have a blog, and we have posts, and the posts have permalinks, and we have 2 instances of our application running. We'll call them instance 1 and instance 2. John and I are both creating a new blog post about this awesome day that we just had, and we're going to call it GORUCO 2011. Well, we both hit save at pretty much the same time. So John's Rails instance goes and says, okay, I'm active record and I have a uniqueness validation, so I'm going to check and see if this permalink exists. Nope. And then before John does anything else, really, my instance goes and does the same thing. All good, right? So uniqueness validated, we're going to save this unique thing, and then we both go and we both save, and on the upside, it's almost unique. There are only two posts with that permalink, but that's not the kind of off by 1 error we want. So again, if you define uniqueness at the database level, it's just not possible to have duplicate values. Again, this is a guarantee. The other advantage of using unique keys, whenever appropriate, is that it allows when you're selecting and using that key in the query plan, it's faster if it's unique because basically the database knows when it finds the value once, it's never going to find it again. This is also particularly where has-one relationships go. Your foreign keys should be unique. That's going to be good for you for performance and just for keeping your data definitely correct. This isn't an actual property of the column. It's a property of the index. But Rails migrations still give us a great way to do that. So I've been kind of trashing validations a little bit here. or talking about where they fall over, where they're not really enough. But validations are pretty awesome, right? Validations are probably like migrations, one of the things that drew us to Rails in the first place. Finally, we have this consistent way to figure out whether the user input's correct, and then if not, have a nice interface to just go back to the user and say, sorry, this isn't going to work. So I'm not saying don't use validations. Validations are a good first line of defense because the behavior of the application, in the case of a validation error, is very easy to manage. But if you want your data to actually be correct and consistent, which you do, you got to do it at the database level too. So it's not that unreasonable to just do it in both places. Just make sure anytime you want something to be present, you both validate present, want it to be present, you validate presence of, and have your non-null column, et cetera. Although John wrote a pretty cool library called database validation, which basically takes the same theory of how active record constructs the model itself by introspecting the database schema and just extends that to validation. So it says if it's a 32-character column, then we're validating length maximum 32 automatically, right, without you having to do anything. And so that that takes you back to only having to do the work once. It's drier. Oh, puppy break. How's that one? It's a little squashed. That one's only squashed on my screen.
So enums are another feature of relational databases. They like your haircut. Enums like your haircut. They are a type that only can take only a certain set of values. So you actually, when you're defining it inside the database, you're saying this is an enum, and it can take maybe gender male or gender female, or it can take face awesome or not awesome. And the cool thing about enums is that in the database, at the database level, they're stored much the same way that an integer would be stored. So there's only a certain number of values. It's not like a varchar. You're not keeping all of this space for each single one, which also has a benefit when you go to query against an enum column. It's considerably more performant. We made a massive migration at Patch, where we both used to work, over to enums, and I'm going to talk a little bit about what's involved there and why you would want to use them. So the first reason you'd want to use them is single table inheritance type columns. There's a certain number of things that that a certain table can represent. You want to use them. Polymorphic association star underscore type columns. If you want to use polymorphic associations, which I don't advise that you ever use, polymorphic's not even the right word for that. Then you should definitely make them an enum. Access state machine state columns, if you're having an object that goes from a pending to an approved state to a revoked state. This is another good use for polymorphics. Really anything that can have a defined set of values that doesn't change too often. And the reason you don't want them to change too often, I'll discuss in a second. So they're easy in MySQL. This is a migration that creates a column. We use a string, and we say the number of different values you can have. You can also use this with rename column. And the cool thing is that your application doesn't have to change at all. Absolutely nothing about your application has to change. The way that these are accessed, if you're using MySQL, is exactly the same as a string. They're brought in as strings. They look like strings. They work like strings. Everything just works. If you're using Postgres, it's a little bit harder. And by the way, you can find gems very easily out there that allow this all to happen across different databases easily. The Postgres adapter seems to have a little bit more trouble, but still pretty reasonable. A gotcha is that if you're using schema.rb to regenerate your schema in multiple places, enums are not a supported type inside of Rails. So your tests will appear to allow a certain type, and then when you go to production, disallow that type or set it to null, and you'll find that records just aren't getting saved. And the reason is because schema.rb in your tests told you things were OK when they weren't. So be careful when you're adding new types to an enum field. This puppy. This is my favorite one, I think. I like the next one, too.
Oh, good. Well, you all have something to look forward to.
Brace yourselves.
Yeah. So one of the things that we like about databases in general, that we like about Mongo, for instance. One of the things we like about Mongo is that it understands certain concepts that are important to us. So in Mongo's case, it understands essentially an object structure, right? You're working with JSON. You have this embedded, you have embedded objects, and you have arrays and all sorts of things, right? So it internally maps to certain concepts that we find useful in our application programming. Similarly, Redis is really cool because it maps data structures, right? So we can use sets and we can use arrays and hashes and that kind of thing. And again, Redis has an implicit understanding of what we're trying to do. Now, SQL databases, for the most part, have an understanding that we don't usually take advantage of, which is an explicit understanding of relationships between objects. So we all use foreign keys, I'm pretty sure, but we just make columns that are foreign keys. And in our head, they're foreign keys, and our application thinks of them as foreign keys, and we use belongs to, and has many to tell the framework that they're foreign keys. But the database just thinks of it as an int column. So for whatever reason, and we'll go over some reasons why we might not want to do this, but we can tell the database, hey, this column refers specifically to a primary key on another table. Here's the one that it is. You know this now, database. And what's cool about that is that once you do that, the database will not allow invalid foreign keys. So it will make it impossible for you to have a foreign key that references a primary key that does not exist in the table. And you have a few options for what happens. Oh, well, I'm sorry, let's look at this first. So here's where we get away from what migrations support at all. But 3 lines of SQL in your migration, that's not bad. So that's in MySQL, that's all you gotta do. So the base option for what to do if a change is going to cause a foreign key to be invalid is to just reject it and just throw an error. We, however, can define triggers that will either perhaps nullify the foreign key, or if it's like a delete, we can actually cascade that delete to the referent of the foreign key, which is great, right? It acts a lot like a dependent option. Semantically, it's very much the same thing, the dependent option that we use in Active Record. The difference, of course, is that if you have lifecycle hooks on your objects in Active Record, those aren't going to fire because this is all happening at the database level. So, what you could do is you could really take it to the next level. So this is just a specific type of trigger that is associated with, cascading foreign keys, but they're actually general triggers that you can define in databases, and these are supported in all the databases we use, where you can say, if thus and such happens, then do this, and you can actually run a full stored procedure. I know, scary stored. I even think they're scary, but you can do this. And so, if your goal is to really, if you're using lifecycle hooks to maintain, to make sure that your data is always consistent, and your database state is consistent, you can do that all in the database, and then suddenly, you have this great management system that's all happening at one layer. It's not requiring a lot of back and forth with your application. Not gonna lie, I've never actually implemented it that way, but it can be done. And if you're using lifecycle hooks, by the way, for things that do not involve just keeping your data kind of intact, I would reconsider. So ups and downs. We guarantee referential integrity, we know that, right? So we never have a situation where a foreign key is referencing something that doesn't actually exist. It also takes care of, if you haven't explicitly created an index on your foreign key, it's gonna do that for you. Not a big deal, you could also just remember to create the indexes, but it's one less step. However, you are gonna have a performance hit on writes because the database does have to be doing this extra work to maintain integrity. So it's not free. But if you're not in a write-intensive situation and you want to know that your data is correct, then it's a good option. And I want to talk a little bit more about guarantees. So when we write code, when we build applications, or even when we build 10 lines of code, we are constantly either explicitly or implicitly deciding what's possible and what's not, what cases we need to handle and what cases we don't need to handle. And different languages give us different tools for doing this. So for instance, a statically typed language really narrows the scope of what's possible. Whereas a duck type language like Ruby, well, when you get an object, anything's possible. You can either make assumptions and hope they don't break, or you can do pattern batching. But either way, we are generally, as Rubyists, used to a wide range of possibilities and not necessarily writing explicit handling for all of them. These tools for building your schema in a more robust way, they're a way to reduce the range of possibilities that you have to deal with, to reduce the set of error conditions. Yeah, this is probably, it's not news that these exist, but if you're not doing this, and I know a lot of good programmers who don't do this, do it, because then you just have fewer surprises down the line. This is John's favorite, I guess.
Is it? Yeah, I think so.
All right. All right, so we're gonna breeze through this last part because I want to leave a little time for questions. So we all know what single table inheritance does. We have a type column, and then active record instantiates the type that's named in that column. If you're going to do this, use enums. But think about whether it's actually a good idea. So it's the rule that I try to use is if the only difference between subclasses is behavior, and the data is exactly the same for all of the subclasses that you're dealing with, then STI is fine. It's good. Gets the job done. However, if as soon as you run into a situation where one subclass has some instance data that doesn't make sense for another one, you're coming up with kind of a crufty schema here, and you should consider an alternative. And that alternative isn't, as far as I know, talked about much in the Rails world, but it's a very common pattern generally in object relational design, which is class table inheritance. So basically, all of the classes in your inheritance hierarchy are going to share some data, right? So we have one table for all the shared data. But then our subclasses each have their own table that references the base classes table, and those subclasses tables have their specific data that only they need. So just a simple example, we have vehicles for getting around, and two types of vehicles are cars and fighter jets. So all vehicles have a make and a model or something like that, but fighter jets have missiles, which cars usually don't. So this way we are only storing the data that's relevant for each individual row, right? Now, there are ORMs out there that have explicit support for this. Active record is very much not one of them. So we're going to show some really unreadable code here that's just like a really, really naive take at how we might make this work. So we're not going to use actual inheritance in Ruby because that would be kind of a nightmare. But we'll use encapsulation and then try to make it feel like inheritance. So basically, we've got this is part one. We can call inherits from. We're going to make sure that the parent part of it is always there. And then for our instance methods, when you get a method missing, first we're going to send it down the chain because active record base may need to handle it. But if we get a no method error there, then we'll try sending it to the class that represents our base class. And then if that doesn't work, then we'll actually throw the original no method error because we want it, that's going to make more sense to the caller. There are libraries out there that attempt this. I think it would be really cool to try to actually build class table inheritance support in active record that it was actual inheritance in Ruby, but it seems, I don't know, like you'd have to write a lot of tests, which is fine.
Yeah, I think this is the one.
Is that the one?
Yeah, not stretched out. It's not, it's kind of runty, I guess.
It's all good. It's all good.
All right. So the wrap is really that you should start thinking of databases as data structures. Don't be afraid to use more than one, but make sure that when you choose one, you're making an informed decision about it. Don't choose Mongo just because the kid down the street with the thick frame glasses chooses Mongo. you need to choose a database based on the characteristics of what you want to represent. If what you want to represent is tables and you work at a bank, you should probably use a relational store.
Sorry.
Whoa, spoiler.
It's my belief that any sufficiently mature application is probably going to be using a combination of data stores. Just like you're probably not going to store all of your data in memory and hashes, you're probably not best off storing all of your data persistent in a single type of database. Databases are tools, so approach each problem individually. And relational databases are a great tool.
This is the last puppy.
And let's take some questions. No questions. Wow, we were really convincing.
Everybody's coding on their Mongo.
Yeah, everyone's like, absurd. All right. Well, thanks, everyone. Oh, wait, do we have one?
We had
we
one.
finally have one?
We had one.
We had one? No? Nah.
Thank you.
Thanks.